In this ACT video, we're going to review quadrilaterals. In our previous video on polygons, we talked about quadrilaterals and I emphasized that the prefix quad means four, and a quadrilateral is just a four-sided polygon. Now, it can just have four sides of any length and shape, but remember, a polygon is formed with segments. There's no gaps, it's closed, and there's no overlaps. So any four-sided figure would be classified as a quadrilateral, but we're going to focus on our more common quadrilaterals like the square, parallelogram, rhombus, trapezoid, etc. We're going to start with our family of parallelograms, and starting basically with just the parallelogram, and then it's going to flow down into some of those other common quadrilaterals that I mentioned. What we want to look at right now are the characteristics or the properties. So the word parallelogram has the word parallel in it, and so our first characteristic is both pairs of opposite sides are parallel. So we're going to mark this figure up. This side is parallel to this side, and this side is parallel to this side. Okay? Our second characteristic says opposite sides are congruent. So the opposite sides are congruent. We'll mark those with those little tick marks that mean congruent. And this one gets 2 and this one gets 2. And since those both have 2, that means they're congruent. And since the one on the left and the one on the right both have 1 tick mark, those are congruent. All right, also need to include that the opposite angles are congruent. So right here, this angle and opposite of it is congruent to this angle. And then up here, we'll use 2 of these little arcs to mark that angle, and it's congruent to that angle. And the fourth property we have is consecutive angles are supplementary. So what that means is, say this angle is 150 degrees and supplementary means the sum is equal to 180. That would mean this angle is 30 degrees. This angle's 30, so 150 and 30 makes 180. The word consecutive means like one right after another. All right, now this 150 is consecutive with this angle, and this angle also measures 30. So you can see these two are consecutive, but then these two opposite angles are both 30 as well. And then that makes this 150 because opposite angles are congruent, or you can think about these consecutive angles. We've got these two right here, or these two at the bottom. And don't forget, with a quadrilateral, the sum of the 4 angles is 360 degrees. All right, I want to take those angles off of there. They might not be the measures every time, but we've got the properties kind of marked up on the figure. Now, from the parallelogram, we're going to branch out and talk about the rectangle and the rhombus. And both of these figures have the same properties of a parallelogram, but then they have some extra ones as well. So let's start with the rectangle. And just like the parallelogram, the opposite sides are parallel, so we can mark those. And the opposite sides are congruent, so I'm marking these just the same as I did before. And then not only are the opposite angles congruent to each other, but more specifically, all 4 angles measure 90 degrees. Okay, and 90 plus 90 plus 90 plus 90, 360. And those consecutive angles are still supplementary because 90 and 90 is 180, or at the top, 90 and 90 is 180. So that still holds true. We just know specifically what those measures are now. And then something neat here is the diagonals are congruent. So if I named this rectangle A, B, B, and I drew, let's see, we need another color. Let's use purple. If I drew diagonal AC, and then I draw a diagonal BD, those two diagonals are the same length. So we could say that segment AC is congruent to segment BD. Now, similarly, the rhombus is another more specific type of parallelogram. The same properties hold true for the rhombus. The opposite sides are parallel. So let's mark those as parallel. And the opposite sides are also congruent, but more specifically, all four sides are congruent. So we just need one tick mark for all four sides. All four sides are all the same length. The opposite angles are congruent. So we can mark this one and this one. And then this angle up here is congruent to this angle down here. And then what's neat about the diagonals here is the diagonals are perpendicular. So let's name this triangle W, X, Y, and Z. And then I'm going to draw some diagonals in there. And WY crosses XZ at a 90-degree angle right there. That's 90 degrees. So we can say that WY is perpendicular, there's your symbol for perpendicular, to segment XZ. And also those consecutive angles are supplementary, just the same. Now, if the rectangle and the rhombus got married and had a baby, they would have a square. The square holds all the properties of the parallelogram, the rectangle, and the rhombus. So this is going to get a little bit cramped up on here because the square's got a lot going on. The opposite sides are parallel to each other. The opposite sides, all four sides actually, all four sides are the same length in a square. The opposite angles are congruent, but more specifically, they all measure 90 degrees. And we need some diagonals, so let's draw some diagonals here. Let's use orange. And we'll draw this diagonal and this diagonal. And then let's name this, what can we name this one? Maybe L, M, N, P. Okay? So this is square LMNP. Line or segment LN intersects MP at a 90-degree angle, and those two diagonals are congruent. So we can say that LN is congruent to MP, and we can also say that LN is perpendicular to MP. So the square has really got it going on. Now, one other thing we want to mention about some of these diagonals, I didn't draw any diagonals in the parallelogram, but we certainly can. One more thing, let's add. The diagonals bisect each other. Do you remember what bisect means? Bi means two and sect is like section. So they cut each other in half. So let's add one more parallelogram property. And I'm not really going to have room to put it on the other figures, but we can, as far as names go, but let's do this. This is congruent to this segment, and this segment is congruent to this segment. So that's the same thing here, congruent, congruent. And then, since the diagonals in a rectangle are congruent, if this piece is congruent to this piece, then this piece has to be congruent to this piece. So in the rectangle, those all four little segments are congruent to each other. And this is congruent to this. Over here in the rhombus, congruent, congruent. And then in the rectangle, all those little pieces are congruent. So lots going on there with the square. I said rectangle, but I meant square. Now, what happens is all squares are rectangles but not all rectangles are squares. Because the square holds all the properties of the rectangle, the square is also called a rectangle. The square is also a parallelogram, but its more specific name is a square because that is more descriptive, because that is all the properties of the parallelogram, the rectangle, the rhombus, and then that makes the square. But that's always a good question. Is a square a rectangle, or is a rectangle a square? And a square is a rectangle, but not all rectangles are squares. Likewise, not all rhombi, which that is the plural for rhombus, not all rhombi are squares, but all squares are rhombi. But all rhombi are parallelograms. So it works its way up, but it doesn't work its way down. Now, let's talk about the trapezoid. With the trapezoid, we've got some properties for that as well. And it's a quadrilateral, of course, 4 sides, with one pair of opposite sides parallel. So this would be parallel to this, and we might call those bases. And then the angles of the same leg are supplementary. So the parallel sides are called bases, and then we call this a leg, and then this is a leg. And that means this angle is supplementary to this angle. I'm just using some dots to show you what I'm talking about. Now, we have some properties about the isosceles trapezoid is much more specific. Much like an isosceles triangle, the legs are congruent. So this would be a base, and the bases are parallel. And this would be a leg, and this would be a leg, but since it's isosceles, the legs are congruent to each other. Now, the base angles. The base angles are the angles formed by the base and the leg. Well, what's happening is your base angles are congruent. So let's call this trapezoid just ABCD. That means angle D is congruent to angle C, and angle A is congruent to angle B. That'll help you figure out some of your missing angle measures in questions. Now we're going to add one more segment here called the median. And much like when we talked about mean, median, and mode, the median of a set of data is the middle number. Well, the median in a trapezoid is the segment connecting the midpoint of the legs. So I'm just going to estimate, but we'll call that the median right there. And the median is also parallel to the bases. So let's put a little parallel sign there. And it is half the sum of the bases. So let's name this median XY. And how would I say this last piece? It's half of the sum of the bases. Well, the median, XY, is equal to 1/2 the sum of AB plus DC. Take the length of AB, add it to the length of DC, divide it by 2. So if AB was, say, 4, and DC is 12, then we would say that XY is half of 4 plus 12, which is half of 16, which would give us 8. So that's how you can figure that out. All right, so that's the isosceles trapezoid, not to be confused with the isosceles triangle. Let's look at a couple of examples you might see. Here we go. Which of the following statements is not true? All right. Question part A. A square is a rectangle. A square is a rectangle. Okay, that's a square is a rectangle, but a rectangle is not a square. So that's true. A square is also a rhombus. That's true. It holds all the qualities that a rhombus has. A rectangle is a parallelogram. That's true because a rectangle has the properties of a parallelogram, but a parallelogram may not have the properties of a rectangle. All right, D says adjacent sides of a rhombus are perpendicular. All right, that does not sound true. Remember, adjacent sides means next to, and to me, the rhombus, even though this isn't the best picture, looks kind of like a square, but smushed over to the side. And if they were perpendicular, that would mean that those are 90 degrees. And that angle is not 90 degrees. So I'm going to say that's false. But let's just check E. Opposite sides of a parallelogram are congruent. That's definitely true. So which one's not true? The answer would be D. So it's very important to know your properties of parallelograms for questions like this, or if you need to find missing pieces to a parallelogram. And our second question says, in parallelogram ABCD, the measure of angle B is 90 degrees. Well, I would try to draw a picture. And I know this is ABCD. And I know it holds all the characteristics of a parallelogram. And I know that angle B is 90 because that was given. Well, I know that the opposite angles in a parallelogram are congruent, so that makes angle D 90. I also know that consecutive angles are supplementary, so that means angle A plus angle D has to equal 180. So if angle D is 90, then that means angle A must be 90. And then angle C must be 90. So if all four angles are 90 degrees, and this is definitely a parallelogram, it looks like we more specifically have a rectangle. Okay, so I would study very hard on the properties of parallelograms and understand that a square is a rectangle, but a rectangle is not a square. Likewise for rhombus, and then working your way back up the flow chart to a parallelogram.